Welcome to IB Chemistry channel. Today through our lesson, I'm going to teach you how to complete and to balance different types of chemical reactions. I'm going to give you all the study tips needed in order to be able to complete and to balance different types of chemical reactions easily. At the end of our lesson, we're going also to practice on some past paper questions. So let's get started. The first thing before starting with completing and balancing, I've got here some important terms we need to revise together. The first thing we need to go through, what is the meaning of the valency? Going to the definition of valency, it is the capacity of an atom to lose or to gain or to share electrons in order to achieve the stable state, which is the octet state. Here we need to remember that each atom, in order to become stable, it will either lose or gain, or it will share electrons. In this situation, I'm going to have either an ionic bond between the atoms or covalent. When the atom loses, gains, or share, there will be a charge that will appear on the atom. The tendency to lose or to gain, it is in order to reach Octet Rule. Going to the meaning of Octet Rule, it is the tendency of an atom to have 8 electrons in their valence shell. And when talking about 8, so I'm talking about an electronic configuration which is very close to be as a noble gas electronic configuration. If we have 8 electrons as valence, and talking about the valence shell, it is the outer shell electrons. So they are the electrons presented inside the outer shell. I have another important definition that we need to go through, which is the oxidation state. When talking about the oxidation state, it's actually the charge that can an atom have after losing or gaining electrons when forming a chemical bond. Here we need to remember that whenever an atom loses electrons, the charge that will appear, it will be a positive charge. In this situation, the protons will be higher than the electrons number. But if the atom gained electrons, so the electrons have been gained, so in this situation, the charge that will appear on the atom, it will be a negative charge. Whenever we want to complete or to balance chemical equations, so we need to write down the chemical formula. We're going to go through the meaning of chemical formula, and we're going to learn how to write down the chemical formula. In order to be able to write the chemical formula, we need to consider the charge of the atom. So let's go deeper into the oxidation state. This is the periodic table, and I have inside the periodic table the oxidation states for the main groups, and it is so important to know them. Remember that the periodic table is attached with you inside the exam. So these charges can be easily identified according to the position of the element inside the periodic table. Let's start with group number 1. As mentioned inside the slide, if you've got an element presented in group number 1, so the charge definitely is positive 1. The reason behind that is the element presented in group 1, it has 1 valence electrons. So in order to become stable, it tends to lose this electron in order to become stable. Continuing with the group number 2, the element, it will be stabilized after losing 2 electrons, so it is positive 2. Continuing with the group number 3, we are talking about positive 3. Continuing with group number 5, I've got negative 3. Here I need to remember that group number 5, any element presented inside got 5 electrons as valence. So when talking about 5 electrons presented, so the question is how many electrons are needed to become stable? When talking about stability, another time it's the octet rule, and the octet rule says that it is 8, so I need 3 electrons to become stable. Why it is negative in charge? Since the element gained these electrons. So I've got gaining of electrons right here. So for a group number 5, it will be a negative 3. Continuing with group number 6, of course, I need another 2 electrons and it is a negative 2. Finally, I have a group number 7, which is negative 1. It will only gain 1 electron to become stable. Going through the main groups, so it is so important to memorize these oxidation state as positive 1, positive 2, positive 3. In case of element presented in group number 4, the group number 4 element tends to share, so the sharing part as an oxidation state, it will be different, and I've got another rule for it. It's not so important to go through it for now. I have now group number 5, which is negative 3, negative 2, negative 1. Of course, if the element is presented in group number 8, so it will not gain, lose, or share. It's the noble gas. I've got here a small note presented at the bottom of the slide. By losing or gaining or sharing electrons, an atom can become stable. Its electron configuration will become similar to a noble gas configuration. And this is essential when talking about octet rule, the tendency to become stable as a noble gas. I've got here another important oxidation states, but they are totally different than the ones that we discussed previously. Here I have the oxidation state of transition metals, and I have the oxidation state of some common polyatomic ions. When talking about polyatomic ions, what's the meaning of polyatomic ions? Going through the word of poly, it's more than one. More than one atom, so it's more than one atom. They join together in order to form an ion, to have an ion. These polyatomic ions, their oxidation state, their formula should be memorized. So it is so essential to go through them and to memorize them. So it is written right here. It's for memorizing. Let's look for the transition metals one. For iron, for example, I have 2 different oxidation states. And for lead, I have another 2 different oxidation states as positive 2 and positive 4. Copper, I have positive 1, positive 2. Zinc, it's a positive 2. Silver, it's a positive 1. The transition metals, as one of their properties, they have variable oxidation state. They have different oxidation state. And of course, the reason behind that, it will be discussed in the chapter of transition metals, which is chapter number 3 as a higher level. And it's related to their electronic configuration. So these transition metals are the most common transition metals inside the past paper, so make sure to memorize them. For the common polyatomic ions, I've got a lot of ions. Going through them another time, it's the memorizing part. I got ammonium, NH4 positive, bicarbonate, or it is named as hydrogen carbonate. It is HCO3 negative. I have the carbonate, which is very similar to the bi without the presence of hydrogen, so it's a -2. Chromate, CrO4 -2, dichromate, Cr2O7 -2, cyanide, hydroxide, nitrate, permanganate, phosphate, sulfate, and sulfite. There is one thing which is so essential here. It is only something that you need to be familiar on. In the polyatomic ions, we have different between the ending of ATE or the ending of the ITE. For the ATE, it is 1 oxygen more than the ITE. So for nitrate, it is an NO3 negative. For nitrite, it is NO2 negative. For sulfate, it is SO4 -2. For sulfite, it is SO3 -2. So make sure to distinguish between them when talking about the chemical formula, of course. For the carbonate, it is CO3 negative. For the hydroxide, I'm trying to put a tick on the most common ones inside the past paper. They ask a lot of ammonium, carbonate, hydroxide, nitrate, nitrite, permanganate, phosphate. So make sure to memorize them. In order to be able to complete and to balance different types of chemical reactions, it is so important to go through the chemical formula. So now we're going to study together how can we find the chemical formula of different ionic compound. Here, when talking about chemical formula, it is the number of atoms presented inside the compound. So how can we do that? We're going to learn together a cross-multiply rule. Let's start with the first example. Magnesium nitrate. Any chemical formula starts with the metal, which is usually the positive charge, and the second part is the negative, which is the non-metal. So we will write down what is the symbol of magnesium under its name and the symbol of the nitrate ion, which is taken from the polyatomic ions. Now you will put the oxidation state under each atom without the charge, taking into consideration either its position in the periodic table or the common polyatomic ions that you need to memorize. Magnesium is presented in group number 2, so it's a 2. Nitrate, it's a 1 according to the polyatomic ion sheet. Then you cross multiply, so your final answer, it is Mg, which is multiplied by 1. The NO3 is all as a polyatomic ion is multiplied by 2, so you need to use a brackets. Continuing now with the second example. Potassium is a K. Now talking about the nitride. If the element ends with IDE, so we are talking about a simple nitrogen presented, which is taken from the periodic table. This would be different than nitrite as ITE and nitrate as ATE. We're going to consider the difference later in example 3 and 4. So as a nitride, as IDE, it is the simple nitrogen. Potassium is in a group number 1, nitrogen is a 5, so it's a -3. We cross multiply, so my formula is K3N. Continuing with lithium nitrite. So I have here the ITE ending. Lithium is Li. The nitrite, it is a polyatomic ion, which is NO2. Lithium is in group number 1. The NO2 is 1. After cross multiply, you're going to write the formula. In this situation, the NO2 is multiplied by 1. Since it is multiplied by 1, so there is no need to put a brackets. So it's not important here to put a brackets. So anytime if the polyatomic ion, which is more than one atom, multiplied by a number which is larger than 1, you will use a brackets. Ammonium nitrate. Ammonium, it's the NH4, which is a polyatomic ion. Nitrate is the NO3, so I have here ATE. The ammonium, it's a 1, the NO3 is a 1. Another time, each one is multiplied by 1, so no need to use the brackets. And your final answer is NH4NO3. Calcium phosphate, the calcium is the Ca. The phosphate is a polyatomic ion, which is PO4. Calcium is 2, PO4 is 3. Cross multiply, so this is Ca. You need a brackets now since the PO4 is multiplied by 2. For the copper 2 hydroxide, now we're going to learn why do we have in Latin between brackets the 2. If you remember, the copper, it has 2 different oxidation states. It could be a positive 1 or it could be a positive 2, and this is mentioned right here. So in this situation, in order to know which one is the correct oxidation state when applying on the cross multiply, the question will tell you exactly what is the oxidation state. So the 2 of the copper, which is right here, it stands for the valency of the copper, or the oxidation state, which is 2. The hydroxide, it is the OH, a polyatomic ion. Then you cross multiply. So it's a Cu, you will use OH between brackets by 2 since it is multiplied by 2. Iron 3 sulfate, another time I have the 3, which is the oxidation state of iron. The sulfate, it is SO4, and I'm going to put a 2 under the sulfate as a polyatomic ion. So your final answer is Fe2 between brackets SO4, then there is a 3 right here. Iron 2 sulfide, so it is an Fe. Now the ending part here is IDE. Another time, make sure that you know the difference between the 8, between the ide. They are totally different in chemistry. I'm going also to highlight them in another color. So I have here the 8. I have here the ide. The same situation here. I have the 8. I have the ide, DE, and the IT. So there is difference between each one of them. Now, going back another time to the question, it is the iron IDE. So I'm talking about simple sulfur taken from the periodic table. So this is the S. Iron is 2. The sulfur, it's a 2. Here you can simplify. So it will become a 1 and a 1 for each. So you can simply simplify if there is a common factor combining between the two numbers of the oxidation state. Aluminum bromide, so it is Al, and you have the Br. Aluminum is in group number 3. The Br is a halogen, so it's a 1, group number 7. So this is Al between brackets Br by 3. Zinc carbonate, it is the Zn and the CO3 as a polyatomic ion. The Zn is a 2 and the CO3 is another 2. You can also simplify, so it will become ZnCO3. We have now the lead 4 oxide, so it's the Pb. The oxidation state is 4. Oxygen, the oxidation state for the oxygen, it is considered as 2. Here we can simplify, so this will become a 2 and this will become a 1, and finally this is PbO2. The last example, it's the Ag as silver. Fluoride is a halogen, this is 1 and 1. And it is AgF. So for the chemical formula, you need to remember that it is so important to memorize the oxidation states and the polyatomic ions, beside memorizing the name of each each element or each symbol given in chemistry. Now I have the types of chemical reactions, so we're going to learn the types, so to apply on how to complete and to balance. We have mainly 5 main important types of chemical reactions. I have single replacement reactions, double replacement reactions, synthesis or combination. I have decomposition, I have combustion, which is complete and incomplete. Of course, we need to be able to identify the difference between each. So let's start with the first type of chemical reaction, which is the single replacement reaction. Single replacement reaction is the reaction where a more reactive element replaces another inside a compound. I have here the general equation that shows how a single replacement reaction takes place. A plus BC forms AC plus B. In this situation, 2 elements, they will compete together. And the elements usually that they compete, they are the metals. So A and B, they will compete in order to react with the C, which is the non-metal inside the ionic compound. In order to have a single replacement, the A should be more reactive than the B. If A is more reactive than B, so it will react with the C, and the B, it will be replaced outside the chemical reaction in the form of a solid precipitate or bubbles of gas according to the equation that we have. When talking about the reactivity of metals, here we need to refer to the reactivity series. Of course, the reactivity series, it's a lesson taken through redox chemical reactions, chapter number 9. We're going to talk about it in more and more details. In the examples that I'm going to complete inside this lesson, I will take into consideration that the A is always more reactive than B in order to have a chemical reaction. Here I have a simple example. I have 2 metals, which are the zinc and the copper. The zinc is more reactive compared with the copper. Therefore, it will react with the chlorine as shown inside the model. So this forms ZnCl2, and the copper, it will be replaced outside. Now we're going to apply on some questions, and we're going to see how to complete and to balance single replacement reactions. So I have here a simple question. Inside the question, I need to complete and to balance. Here, the Zn and hydrogen, they will compete together. So I'm going to make the Zn and the Cl together. So it will react with the Cl, and the hydrogen, it will be replaced outside from the chemical reaction. So when you want to complete your chemical reaction, you need in this situation to cross multiply between the zinc and between the chlorine. The zinc, it's a 2. The chlorine is a halogen, it's a 1. So you cross multiply and your final answer is ZnCl2 plus the hydrogen, it will be kicked outside from the reaction in a form of hydrogen gas, since it is a diatomic molecule in nature. Here, talking about the balancing part, we need to consider the total number of atoms as reactant and compare it with the total number of atoms as a product. I have 1 Zn as a reactant. I have also 1 Zn, so it's balanced. Continuing with the chlorine and hydrogen, you will find that you have 2 chlorines, 2 hydrogens in each product. You have only 1 and 1 reactant, so you're going to multiply by a whole big 2 beside the hydrochloric acid. Continuing with NaCl and F2, in this situation, the Na will actually react with the fluorine, and the Cl, it will be replaced outside. So you're going to cross multiply between the Na and between the fluorine. Sodium is in group number 1, fluorine is a halogen, group number 7, so it's a 1. This forms NaF plus Cl, it will be in a form of diatomic molecule, so it is Cl2 as a gas. It will appear here as a gas of bubbles. For the balancing part, you have 1 Na and 1 for each side, but you have 2 fluorines, so I'm going to multiply here by 2. In order to balance the sodium another time, I'm going to multiply by 2. Continuing with the last example, the Al and the NO3, they will be reacted together. So Al and NO3, this is a 3, group number 3. The nitrate, it's a polyatomic ion. So your final answer is Al between brackets NO3 by 3 plus the copper, it will be as a solid precipitate. Now we're going to continue with another very important example for the single replacement reaction, into which we're going to learn how, if we have a metal, it may react with water. So, the reaction of alkali metals with water. I've got here a small figure into which I've got a test tube, and inside the test tube we have water. There is a piece of metal that will be introduced. It is an alkali metal, which is a metal presented in group number 1. In this case, it's actually the lithium. It is added to water. The chemical reaction that takes place, it is so essential as a single replacement reaction. You're going to find that the test tube, there is fizzing and there is a heat as well. So there is a chemical reaction here. And after that, it will turn at the end of the reaction into colorless. It turns little bit cloudy, then it becomes disappearance, colorless, since the chemical product form totally dissolved inside water. Now the point is, what would be the product when a metal as an alkali reacts with water liquid? Here we need to remember that our water, it's made up of hydrogen ion besides the OH negative. So we have here a rule, which is the lithium, it will react with the hydroxide, and the hydrogen, it will be replaced out in a form of hydrogen gas. Lithium is in a group number 1, so it's a 1. The hydroxide is 1. So this will form LiOH plus the hydrogen, it will be replaced outside in a form of hydrogen gas. And now we have the balancing. So I have 2 hydrogens, but on the products I have a 1 here and a 2, so it's a total of 3. So the best way to balance is to multiply by 2 for the water in order to have form. I will also multiply by 2 right here, and finally the lithium will be also multiplied by 2. I've got here a very important rule that you need to remember. Anytime you have an alkali metal, so I'm talking about group number 1, lithium, sodium, potassium, rubidium, cesium, francium, any one of these, if they react with water, we have 2 different products. They are so important, which are metal hydroxide and hydrogen gas. The reaction is actually exothermic reaction, so there will be energy as well produced. We will talk about energetics and the energy released from the chemical reactions in chapter number 5. And here, if you go back to the test tube, you're going to find that it turns into colorless. Since the metal hydroxide formed, it's actually soluble inside the water, and the pH of the solution, it will become basic, above 7, since the metal hydroxide, it's actually a base. Another time, acids and bases will be also covered later in chapter number 8. Now we're going to start with the second type of chemical reactions, which is the double replacement reaction. In the double replacement reaction, two compounds, they react to produce two new different compounds. The general equation is AB plus CD. Now, the A will always react with the D. So remember that the fronts together and the middles together. So this will form AD plus, it's not ABC, it's a CB. Now the reason behind that, the A is a positive, the B is the negative as an ionic compound. Here it's a positive and here it's a negative. When writing the ionic compound, we always start with the positive, then we end with the negative. So keep this inside your mind. So inside the double replacement reactions, always remember the fronts together and the middles together as in the example given in the model. So here I have MgO plus calcium sulfide. Magnesium will react with the sulfur. The calcium will react with the oxygen. And this forms MgS, which is magnesium sulfide plus calcium oxide, taking into consideration the chemical formulas and the oxidation states. Now we're going to have some examples to apply on the double replacement. So Ag will react with the NaCl. So Ag with the Cl and Na actually with the NO3. Another time you're going to apply on the cross multiply. Ag and Cl, it's a 1 and 1. So the chemical formula is AgCl. And you have the second compound is NaNO3. You start with the metal, then the non-metal. And also the Na and the NO3, both of them, they are 1 and 1, so they have the same oxidation state. For the balancing, it's already balanced. Continuing with example 2, potassium will react with the NO3 and the barium will react with the sulfate. So doing on the cross multiply to form the chemical formulas, K, you will cross multiply between it and between the NO3. The 2 which is beside the K and the NO3 which is between brackets 2, you will take them into consideration when you balance. So you need to take the single atom or the single polyatomic ion. Potassium is 1, nitrate is 1, so this would be KNO3 plus, now you will cross multiply between the barium and between the sulfate, starting with the metal. Barium group 2, sulfate is 2, you can simply simplify, so it will become a 1 and 1. So your second compound is the barium sulfate. You can start thinking about the balancing part. So you have here barium and sulfate. Now, if we want to balance, we're going to find that the potassium is 2, the nitrate is 2, so I'm going only to multiply by 2 and I'm already done. Example number 3, it is so important and we're going to have a very important rule from it. Na, it will react with the NO3 and the hydrogen, it will react with the CO3. So for the Na and for the NO3, you will also cross multiply. So Na and NO3. And Na group 1, nitrate is 1, cross multiply, it is the NaNO3 plus. Now, the point here, whenever the hydrogen reacts with the carbonate, they will give us two products, which are the carbon dioxide and water. And you should keep these inside your mind. Here, if I'm going to give it in more details, now the hydrogen reacts with the CO3. Hydrogen is 1 and the carbonate is 2. So the product, it is H2CO3. Now, the product formed, which is H2CO3, it's named as the carbonic acid. The carbonic acid is unstable and it will split, forming water and carbon dioxide. And if you count the total number of hydrogens and carbon and oxygens, you compare it with the carbonic acid, you're going to find that they are the same. So from here, we can have a very important rule that we need to keep inside our mind. The rule, If you've got a metal carbonate and anytime it reacts with an acid, so there will be a hydrogen taken from the acid, there will be 3 products, which are salt, carbon dioxide, and water. Going back to the example, I'm going only to balance. So I have 2 sodiums, I'm going to multiply by 2, and already the HNO3 is multiplied by 2, so my chemical balance equation is now balanced. Keep this important rule inside your mind beside the one which is for the alkali metals. We have here a practice. So we're going to have the hydrogen and the AgCl. I'm going to apply it as 2 products will be formed. You have firstly AgCl plus HNO3. I'm trying to do the cross multiply inside my mind. It is already balanced. Now the calcium, it will react with the phosphate. The sodium, it will react with the chlorine. So this will form Ca, and I'm going to open brackets. Since the calcium will be reacted with the phosphate, it's a 3, and the PO4, it is multiplied by 2, plus the NaCl. Now, thinking about the balancing, you're going to find that you have a 3 and a 2 for the Na and the Cl, so you will look for a common factor between them. Then the phosphate is multiplied by 2, so this is a 2. The calcium is a 3. So now the chlorine and the sodium, both of them become 6, so your total is multiplied by 6 as a coefficient. You have here the lead and the chlorine, and you have the barium and the nitrate. So I have Ba, and between brackets, I'm going to open it as NO3 by 2 since it's in group number 2, plus the lead. In this example, it is a transition metal, and its oxidation state is +2, taken from its formula. Now it is already balanced. Now the iron and the hydroxide, and I have the Na and the Cl. So the iron as a 3 oxidation number between brackets, 3 plus NaCl. And after that I have the balancing, so I'm going to multiply by 3 for the NaCl and the NaOH by also 3. I have the H and the CO3, the Na and the SO4. Remember here that we have the rule of the carbonic acid, so this will form Na2SO4 plus the hydrogen and carbonate will split, forming CO2 plus H2O. And finally, we have the balancing part. Looking at it, it is balanced. The last equation, I have K2SO4 plus the copper as hydroxide. It's a +2 taken from the copper sulfate. Oxidation state of sulfate is -2, so the copper is considered as being +2. Finally, I'm going to balance the K. Now we're going to continue with the third type, which is the synthesis or the combination. It's whenever the reaction where 2 substances, they combine in order to form a one single substance. Your general formula is A plus B in order to form AB. So you actually got 2 elements or 2 substances presented. I don't have here any compound. So they will only combine together, and this is called the synthesis. An example, I have Na plus chlorine. This will form your NaCl, and you're going after that to balance. So I need here to exchange little bit the model. So it will be the NaCl, and after that we will do the balancing part, which is to multiply by 2 here and to multiply by 2 beside the Na. Now we're going to apply on more examples for the synthesis chemical reaction. So barium and chlorine, they will combine together, and this will form BaCl2 since the oxidation state of barium is +2. the K and the O, they will react, and your final product is K2O. Now for the balancing, you will multiply by 2 and here by 4. For the Al and the fluorine, you're going to have a 3 here and a 1 right here. So this is AlF3. Now to balance as a common number, I will multiply by 2, by 3 in order to have a 6, and by 2. Continuing with the fourth type, which is the decomposition reaction. For the decomposition reaction, it is the opposite exactly compared to the synthesis. So if you look at the general formula, you're going to find that you have a compound and it will split into two different elements or into the substituent elements from which the compound is made up of. So going to the definition, reaction where one substance or one compound breaks down into two or more substances by heat or electricity. So this is considered as an endothermic chemical reaction. You cannot decompose the substance or the compound if you didn't apply on heat or if you didn't add electricity. So, according to energetic chapter, we need to keep inside our mind that all decomposition reactions, they are considered as endothermic. So I've got here NaCl that splits into the chlorine besides the Na, which are the elements from which my salt is formed. Now, I have the combustion chemical reaction, which is the last type. When a hydrocarbon compound or an organic compound reacts with plenty amount of oxygen, forming carbon dioxide and water. Here, it is so important to recognize that we have two different types of combustions. We have firstly the complete combustion. So this is the first type, complete combustion reaction. In the complete combustion, you will have a hydrocarbon molecule and it will react with a plenty amount of oxygen. So you have a sufficient excess oxygen. So when the hydrocarbon compound reacts with excess oxygen, there will be two products which are carbon dioxide and water. So you need to memorize the products actually. We have another type of combustion which is under a title of incomplete combustion. The difference between both is in the product and in the amount of oxygen presented. So if the organic compound or the hydrocarbon compound reacts with insufficient, so limited amount of oxygen, it will form carbon monoxide instead of the dioxide. So this is the most important difference between both. Now the carbon monoxide, it is actually a toxic gas and you need to know that. Compared with the carbon dioxide causes to have the acid rain, which is also a very essential topic later in acid and bases. So remember, we have two types, complete and incomplete. The difference is in the amount of oxygen and in the products formed. Let's consider some examples for the combustion, and they are very important examples for the externals. So I have CH4 plus oxygen. I will consider that all of them, they are complete as excess amount of oxygens are presented. Here I'm going to teach you how to balance. If you have a combustion, you will start with the carbon, hydrogen, and you will leave the oxygen at the end. So you've got one carbon, you have 4 hydrogens, so I will multiply here by 2. Now I need to count the total number of oxygens presented inside my molecule. So let's start counting for the products part. You have 2 oxygens right here, plus you have another 2, so the total is considered as being 4. So now in order to balance the oxygen, you're going to multiply by 2. This is an easy one. Now, we're going to continue with the others and we're going to see the difference. In the second example, I have 2 carbons, I have only 1, so I will actually multiply by 2 for the carbon dioxide. Talking about the hydrogen, it's a 6 here and the 2 here, so I'm going to multiply by 3. Now, let's count the total number of oxygens. 2 times 2, it's a 4, plus 3, so it's a total of 7. Now, the question is, 2 times what? It's a 7. It is allowed to multiply by a decimal or a fraction. So if you start thinking 2 times what equals 7, so the answer it is 3.5. If the question is telling you to balance and to use full numbers or whole numbers, so you are not allowed to leave it as 3.5. So what you're going to do now, you're going to multiply the whole equation by 2, so it will become 2C2H6 plus 7O2 in order to form 4CO2 plus 6H2O. Now let's take the C2H5OH. I have 2 carbons, I have 1, so multiplied by 2. I have the hydrogens, take the total, it's a 6, so I will multiply by 3. Now, 2 times 2, it's a 4, a plus a 3, so it's a 7. The difference between 3 and 2 is the number of oxygens presented as reactant. Here you have 2 oxygens, but you have here another 1. So you need to start thinking as 1 plus what will equal for the number that you need. So 1 plus your question mark in order to become a 7. So definitely you need a 6. So it is 3. Since 3 times 2 it's a 6 and 6 plus 1 it's equal to 7. The third equation it's for alcohol, and alcohol we've got oxygen, so make sure to count the total number of oxygens correctly. Now for 4 we have 4 carbons, we have only 1, so I will multiply by 4. Hydrogens I will multiply by 5. Now let's count. 4 times 2 it's an 8 plus 5, so equals to 13 another time. What's the number that is 2 times what equals to 13? It is 6.5. Now you're going to another time multiply by 2 in order to overcome the decimal used. So your final answer will become 2C4H10 plus 13 O2 in order to form 8 carbon dioxide plus 10 water molecules. Now we're going to apply on some past paper questions, starting with question number 1. What's the whole number ratio of the coefficients of ammonia to oxygen when the following equation is balanced? So firstly, we need to balance to find out the mole ratio. Nitrogen is 1 for each reactant and product. Continuing with the hydrogen, I have 3 here and I have 2, so to balance I'm going to multiply by 3 and I'm going here to multiply by 2. Continuing with the oxygen, so I need to count the total number of oxygens, but before that the nitrogen now should be also balanced after multiplying by 2, so I'm going to multiply the NO by 2. Now I will add 2 plus 3. My final answer is 5. So now I need to think that 2 times 2.5, it's a 5. I'm not going to leave the equation as decimal places presented, so I need to multiply the whole by 2. So for the ammonia, after multiplying by 2, it will become 4. And 2.5 multiplied by 2, it will become a 5. So the mole ratio for the ammonia to oxygen, it is 4:5, and your answer it's a C. What is the sum of the integer coefficients when propene undergoes complete combustion? So C3H6 plus O2 to form CO2 and H2O. I have here 3 carbons, so I will multiply by 3. Now I will balance the hydrogens. This is propene, so this is a 6. So you will multiply here also by 3 to balance. Now let's start counting the oxygen. 3 times 2, it is considered as a 6, plus a 3, so your final answer is 9. Definitely you need to multiply by 4.8. So 4.5, sorry. So you will multiply it by 4.5. Now you're going to multiply the whole equation by 2. Now what will happen? Inside this question, they are asking me for the sum. So I need to take the coefficients and to add them together. So if you multiply by 2, what will happen? You will have 2C3H6 plus 9O2 in order to form 6CO2 plus another 6COH2O. Now we're going to add all the coefficients presented. So we need to look for the coefficients. I have 2 plus 9 plus 6 plus another 6, and your final answer, it's a 23, and you're going to have a circle for the D. Continuing with more ideas. What is the sum of the coefficients when the equation is balanced with whole number? So another time I need to balance, and I'm going to have the adding of all coefficients. Starting with the Mn, it is 1 and 1 for each. I have 2 oxygens, so I will multiply my water by 2. I have hydrogens, which is considered here as 2. Now looking at the balancing part, you're going to find that it is actually, you need a 4 beside the HCl in order to balance the hydrogens and the chlorine. As total it is 2 and 2. So now it's balanced. I'm going now to count the coefficients. Here it is so important when counting the coefficients is to look for the numbers, all of them. Here it's a 1, so you need to count it. 1 and another 1 here. So it's a 1 plus 4 plus 1 plus 2 plus another 1. And your final answer in this situation is a 9. So you're going to circle the 9. Now, what is the sum of the coefficients when the equation is balanced with whole numbers? Another time, this is a combustion chemical reaction. But in this situation, it is incomplete. As you can see, there is carbon monoxide. This will not affect at all the way of thinking. So you have 8 carbons. Hydrogens, it is 18. So you will multiply by 9. Now you count 8 plus 9 equal to 17. So you will multiply by 8.5, and then you will multiply the whole equation by 2. So after multiplying by 2, you will have 2 in case of C8H18. You will have another 17 for the oxygen. You will have another 16, and you have another 18. Now you will add them all together since the question is asking about the sum of the coefficients, and your final answer, it will be equal to 53 when you add all these coefficients together. Now I have the last idea as a multiple choice when you want to go through your past papers. Which expression gives the sum of all the coefficients for the general equation for the complete combustion of hydrocarbon? Actually, this is a general equation for any complete combustion for a hydrocarbon. So if you've got a hydrocarbon, no matter what's the hydrocarbon that you have, and you've got, or you need to have a general equation that shows the summation of all coefficients after balancing, you have it as a C answer. So I prefer in this situation to keep this as a note inside your copybooks, that the general equation for the hydrocarbon combustion, it is 1 plus 2x plus 3y over 4. So you need to make sure that you know this note. And if you want to double check whether this is correct or not, you can write any equation for any combustion hydrocarbon to balance and to add the coefficients. Then you're going to check with the general equation given, and you're going to find that the answer is a C answer. I'm done with the lesson for today, into which we learn together how to complete and to balance different types of chemical balanced equation, and we consider some of the past paper questions as a multiple choice. Thank you for watching.